Hey everybody, today we're going to work on creating an assembly that makes our screw actually function. So when we turn the knob of the screw, the C-clamp actually closes to the point where it's shut, and then we can unscrew it to the point where it's open. So let's get into that. Okay, so here I am in my assembly. And one thing here that we have to make sure is that the body of our assembly is locked in place. So you can either ground that with like a mate to the origin, or you can right click and select the fix option. That's what I've done. If I were to click unfix, then my piece would be able to move. But I'm going to right click here and say fix, and then that locks that piece in place. So the next thing that I've done here is I've just done a simple fasten constraint between the end of the cap and the inside of the screw, okay? And if I were to like suppress that, realistically we want the end here to be touching this part of the screw, okay? This part of the screw sticks out through, and it would be what's called peened over. If you look at the chart where it explains all the dimensions, it says like lightly peen, which really means that you take like a hammer and an awl or something, and you would basically smack, you'd hit the end here, and that would cause it to mushroom out a little bit, and it would make it wider. So that would basically trap this piece in place in real life, okay? So that piece is attached, so I have these two things attached to one another. So now it's time to like work on the process itself. So the first thing we need is a cylindrical mate. So I'm going to hit M for mates, and like by default it goes to fasten. I'm going to select cylindrical mate. So cylindrical mate is a mate between two cylindrical surfaces, all right? We are going to select the center of the end here, right, which is like the same point that this is attached to, and then we're going to select the center of the hole on this side here, okay, and that puts those two things together. And once we click the checkbox, this thing's going to snap down into place too, because I have a fixed constraint on that. But before we do that, we want to set some limits. Well, let's just click the check and then we'll go back in and edit. So when I move this thing now, we can see it moves and it stays within that cylindrical object, but notice it like slides in and out like there's nothing stopping it. I'm going to double click again on cylindrical 1. I'm going to select limits. So our minimum limit is 0 inches for this thing, and the maximum limit is 2.125 or 2 1/8. And we're going to click the checkbox. Now, the furthest that it can go out towards the left is where it is right now, and then when I click and I drag this over this way, the furthest it can go this way is there, okay? So that defines like our open and closed positions of our piece. Okay, so now we need to make it so that when we turn the handle, it forces this thing to move in and out in a controlled kind of way. Like right now it just basically moves haphazardly because when I go to rotate this, it's also trying to like move. So this isn't a mate, this is up here. This is what's called a screw relation, okay? So we can constrain, or basically use a constraint between these 2 points to make this thing happen, okay? So the first thing we need to do is what mate do you want to use for this? And in this case, it's the cylindrical mate that we just created. So we're going to select that mate. Without selecting that, none of this is going to work. Then it says, okay, what's the distance per revolution? So technically, this is a 3/8/16 thread. So there are 16 threads per inch, so that means that for every 1 revolution we turn, we're going to move 1/16 of an inch. So I'm going to type 1 divided by 16, or 1/16. I'm going to click the checkbox. Now when I turn this thing, now I can't just like drag this thing back and forth, okay? It is kind of like locked in place. But when I spin this thing, now it moves closer, and when I spin it the opposite way, it moves further. Now the reality is, although that is technically the most correct that it possibly can be. Like physically, this thing moves 1/16 of an inch per revolution. The act of like actually moving it at 1/16 per inch is just kind of excruciatingly long in this process here. So sometimes I exaggerate like the movement. So like instead of 1/16 here, I think like a 1/4 movement is almost better. Again, technically it's not correct, but visually it just works a little bit better, you know. Now we have a lot less turns that we need to go through to make this thing open and close. Alright, so in the end, your screw can either be 1/16 or it can be up to 1/4 of an inch per revolution. Anywhere in between those 2 points is perfectly okay as far as I'm concerned. Again, the 16th is more accurate, but the 1/4 just kind of animates a little bit better, looks a little better. So either option's good by me. Get your piece to move, make sure that it starts and stops where it is supposed to. Like when I rotate this thing in, it will not rotate past that point. Like that's as far in as it goes. Same thing on the back side, which is going to take me far too long to get to. But the biggest that it will get is that point there. And then it kind of like gets stuck there. Alright? So that's the goal for that. Okay. Bye-bye.